I want you to start by picturing something for me, right, wherever you were listening to this.
Okay.
I want you to imagine the cardiovascular system
Yeah.
of a major modern city.
Oh, that's a good visual.
Right. So think about a sprawling metropolis. Think about, New York or London, Mumbai, Tokyo, anywhere like that.
Yeah, massive scale.
Exactly. And if the massive underground pipes are the veins and the arteries carrying the literal lifeblood of the city, what is acting as the heart valves?
Right. What's controlling it all?
Yeah. What is acting as the filters, the pacemakers, the complex biological mechanisms that actually control where that water goes?
Because it doesn't just flow on its own.
No, it has to be managed, like
Yeah.
how fast it moves, what impurities get stripped out along the way.
Yeah.
Because honestly, a pipe without control is just a flood waiting to happen.
It really is. And the sheer physics of that visualization, they're staggering when you really map it out.
Yeah.
Because we all see the tap in our kitchen, right? And we all see the storm drain on the street corner.
The visible stuff.
Exactly. But we operate completely blind to the vital organs functioning in the subterranean dark.
It's totally invisible to us.
Completely invisible. We are talking about literally millions of gallons of water, and it's moving under immense pressure 24 hours a day, 7 days a week.
It never stops.
Never. So it requires a level of mechanical control that most people just never spend a single second thinking about.
Which is wild, honestly, considering it's the only thing keeping us all alive.
Basically, yeah.
So welcome to the deep dive. Our mission today is to take a towering stack of financial reports, market analyses, and detailed company profiles centered on a single fascinating industrial player.
And it is a fascinating one.
It really is. It's a company called JASH Engineering Limited, or JASH for short.
Yeah.
And we're going to extract the absolute core insights from these sources.
We really want to unpack this.
Yeah, we want to understand how a seemingly unglamorous, nuts and bolts, heavy manufacturing business actually sits at the very center of global survival and modern urbanization.
To set the stage for you, the scope of the sources we're synthesizing today is incredibly broad.
Very broad.
Yeah, we're looking at hard data covering JASH's entire product lines as well as their massive global footprint.
Right.
I mean, we are talking about a company exporting to over 45 countries, all the way from their manufacturing base in Indore, India.
Which is a huge reach.
It's massive, and we're dissecting their competitive moats, examining some very sudden and severe recent financial stumbles they've encountered too.
Yeah, those are really interesting.
And we're placing all of this against the backdrop of the massive macroeconomic tailwinds of the global water treatment equipment market.
Just to give you a sense of scale, that specific market is estimated to be, what, a $10 to $20 billion annual industry?
Yeah, roughly 10 to 20 billion annually.
So why should you, the listener, actually care about an Indian valve manufacturer? Let me put it this way.
Go for it.
Whether you're an investor looking to understand how industrial moats are actually built in the real world, because it's very different from how, say, software moats are built.
Whoa, completely different mechanics.
Exactly. Or maybe you're a professional curious about the incredibly fragile global supply chains connecting us all.
Right.
Or, honestly, if you're just someone who wants to understand the invisible infrastructure that is keeping your city functioning right this very second.
Which is a great reason to listen.
This deep dive is going to give you an entirely new lens on the water flowing out of your tap.
The best place to start understanding a company like JAH is to really look at the invisible plumbing of the world.
Yeah, invisible is the key word there.
The word invisible carries so much weight here because the scale of the mechanical intervention that happens between the reservoir and your glass or, between your drain and the ocean, it's monumental.
It's not just a straight pipe.
Not at all. Our sources break down JASH's core product categories into a few highly specialized buckets.
Okay, let's go through them.
First, you have water control gates.
Right.
These are your sluice gates, your flap gates, your weir gates.
Okay.
Then you have screening equipment, which includes fine screens, coarse screens, and microfine screens.
So filtering stuff out.
Exactly.
Yeah.
Beyond that, they manufacture bulk solids handling valves. And finally, heavy process equipment, so things like clarifiers, aerators, and diffusers.
I mean, just the names of these things sound heavy, right? Like sluice gate, clarifier. It sounds like industrial poetry almost.
It does have a certain ring to it.
But to give you a sense of the scale here, the sources detail their actual physical manufacturing output.
Yeah, the numbers are big.
Between their facilities in Indore and Pithampur in India, they're churning out 5,000 nice gate valves a year.
Right.
They're producing 20,000 other types of valves, 250 massive fine screens, and 2,000 tons of fabricated products annually.
It's a massive operation.
Yeah, this isn't some boutique operation. This is like heavy metal.
It is absolute heavy metal, but it is heavy metal deployed against a global crisis.
Yeah, that's the crucial context.
The macro need for these products is driven by some incredibly sobering statistics outlined in our sources.
What kind of stats?
Well, according to the UN data we reviewed, 2.2 billion people globally lack safely managed drinking water services.
2.2 billion. That is, I mean, that's a huge chunk of humanity.
It is. But here is a statistic that usually shocks people even more. Even in high-income developed countries, only about 55% of urban wastewater is actually treated.
Right, let's pause and let that sink in.
Yeah.
You're saying that even in wealthy nations, almost half of the urban wastewater just goes where? It just flows back into the environment, completely untreated.
That is the harsh reality of it, yeah. It flows straight into rivers, lakes, and oceans.
That's horrifying, honestly.
It is. And when you look at lower income or emerging markets, that percentage of treated water drops precipitously.
I can only imagine.
That's the baseline reality of global infrastructure right now. It is severely, dangerously underbuilt.
Wow.
Which brings us directly to the total addressable market, or the TAM. As we mentioned, the sources estimate the global demand for these specific types of water control gates, valves, and screens at roughly $10 to $20 billion annually.
That is a massive pie. And the sources break down how that market is actually penetrated right now, right?
Yeah.
Because an open market is only useful if there's room to grow into it.
The opportunity landscape here is fascinating, honestly. Take water control gates, for example.
Okay.
These are the massive metal barriers that literally hold back or release millions of gallons of water in a dam or a municipal treatment plant.
The big stuff.
Yeah. In developed markets like Europe and the United States, the market penetration for modern compliant equipment is only 20 to 40%.
Wait, really? Only 20 to 40% in places like the U.S.?
Yeah, it's considered a mature market, but it's one that is constantly needing replacement and upgrades.
Why is that?
Mostly due to the simple realities of corrosion and constantly evolving stricter environmental standards. They have to keep updating.
Okay, that makes sense. So what about the emerging markets?
Well, when you look at India and other emerging Asian markets, penetration is sitting at a mere 10 to 20%.
Wow.
So that leaves an open market globally of 60 to 80%.
That is a staggering gap. I mean, it implies the vast majority of the world simply hasn't built the necessary infrastructure yet, or what they do have is completely obsolete.
Exactly. And the structural growth drivers pushing that eventual build-out are virtually unavoidable forces of nature at this point.
Like what?
The UN projects that 68% of the global population will live in urban areas by 2050.
68%.
Yeah, that is a tidal wave of humanity moving into highly concentrated cities.
Right.
To ground this in a specific example from the sources, India alone needs to build over 100 massive new water treatment plants just to handle the 500 million people migrating into its urban centers over the coming decades.
500 million new urban dwellers.
Yeah.
That's more than the population of the U.S. just moving into cities in one country.
Exactly. You fundamentally cannot have high-density urban living without high-capacity water and wastewater treatment. The city simply breaks down.
It would be a disaster.
Furthermore, you have stricter environmental regulations rolling out globally. You've got rising water scarcity affecting 2.4 billion people, and the rapid expansion of heavy industries like steel and power in emerging markets.
And all of those industries require huge amounts of water, right?
Oh, absolutely. They require massive amounts of cooling water and intake equipment.
Okay, let me try an analogy here to help visualize this. Because when I was reading through the sources detailing these product lines, the screens, the clarifiers, the valves, it really struck me.
What's the analogy?
Think of municipal water treatment as a giant, never-ending mechanical digestive tract for a city.
A digestive tract. Okay, that paints quite a picture. Let's trace how that biological system maps to the machinery.
Okay, so you have the coarse and fine screens that JASH builds. Those are the teeth of the system.
Right, they do the chewing.
Exactly.
Yeah.
The raw wastewater comes in off the street, full of debris. I mean, we're talking tree branches, plastic bottles, whatever gets flushed down. The storm drains during a massive storm.
Yeah, all the heavy trash.
So the screens literally chew it up and filter out the big destructive chunks so they don't wreck the downstream pumps.
Makes perfect sense.
Then the water moves into the process equipment, things like the clarifiers and the thickeners. That's the stomach.
The stomach, right?
That is where the heavy organic materials are allowed to settle to the bottom and are separated from the water.
Okay, following so far.
And throughout this entire digestive system, linking the teeth to the stomach to the intestines, you have the valves and the sluice gates.
Ah, okay.
They are the sphincters, the muscular valves that dictate exactly how much flow moves from one organ of the plant to the next, preventing backups and ensuring the whole system doesn't rupture under pressure.
The mechanics of that analogy are actually incredibly sound.
Thank you.
To add some scale to your municipal digestive tract, the sources note that a single, standard-sized municipal wastewater plant requires anywhere from 50 to 250 of these screens and gates just to function at a baseline level.
Wait, up to 250 in one plant?
Yeah. This isn't a situation where a city buys one giant master valve and they're done for the decade.
Right.
It requires massive volume, continuous redundancy, and components scaled to fit varying pipe diameters throughout the facility.
Which brings up a question I've been wrestling with while reading these reports.
Okay.
The sources state the total addressable market is, let's say, $20 billion on the high end.
Right.
But JAH, even with all these massive factories and 800 employees, reported revenue of about $152 million recently.
Yes.
So, if my math is right, they only have roughly 1% of the global market. Why is that?
It's a great question.
I mean, is this just a hyper-fragmented market full of tiny mom-and-pop metal shops? Or is the pie just so incomprehensibly big that even a 1% slice requires a massive multinational operation to capture?
It is largely the latter, but it's complicated by the incredibly localized physical nature of heavy infrastructure.
What do you mean by localized?
Well, the pie is massive, but it is deeply geographically siloed. We have to remember the physical reality of the product.
The heavy metal.
Exactly.
Hmm.
We are talking about shipping incredibly heavy, custom specialized metal fabrications.
Right.
A 10-ton cast iron sluice gate is not something you flat pack and ship via air freight overnight.
Definitely not getting that on Amazon Prime.
No, you're not. The sheer physics and cost of logistics dictate that regional players will almost always dominate their local markets.
Okay, that makes sense.
JASH has managed to export to over 45 countries, which is actually highly unusual for a player their size and speaks to their specific capabilities. But the global market as a whole is still predominantly composed of entrenched regional players serving their local municipal governments.
Okay, so if the market is this fragmented, and the tailwinds are this strong with global urbanization, and the products, let's be perfectly honest here, are essentially just shaped metal, why hasn't everyone set up a foundry?
Right.
Why isn't every massive industrial conglomerate in the world jumping into this space and eating JAS's 1% slice?
The answer to that lies in the specific nature of their competitive moat.
Okay, lay it out for us.
Because when you look at JASH's financials in the sources, something immediately jumps off the page and demands an explanation.
What's that?
The gross margins are structurally high. They hover around 45 to 50%, with recent reports showing them hitting 51.05%.
I need to stop you right there, because a 51% gross margin in heavy capital goods manufacturing is wild.
It is very unusual.
If you're making a software as a service product, sure, 80% margins make sense because the cost of replicating code is zero.
Exactly.
But if you are buying raw iron, melting it in a furnace, casting it in sand, machining it to millimeter tolerances, and shipping it on a flatbed truck, how on earth do you keep 51 cents of every dollar as gross profit?
You achieve that through a very specific, hard-to-replicate combination of what the sources call their technology advantage and their cost advantage.
Okay.
But we need to define technology very carefully in this context.
Right, because we aren't talking about microchips.
No, we aren't talking about proprietary microchips or patented algorithms. We are talking about the agonizingly slow, bureaucratic process of municipal approvals.
Ah, so the red tape is the actual business strategy.
That hits the core of the issue perfectly.
Wow.
Think about it. When a city government issues a public tender to build a new water pumping station, the civil engineers designing that station absolutely cannot risk using an unproven valve from a new supplier.
Why not? Just save a few bucks.
Because think about the stakes. If a massive sluice gate fails, a neighborhood floods, or millions of gallons of raw sewage spill into a public waterway.
Okay, yeah, that's a disaster.
The political fallout and environmental liability are catastrophic. Therefore, municipalities have incredibly strict, draconian approval processes.
So what does a new manufacturer have to do?
An equipment manufacturer has to submit exhaustive designs, undergo extensive third-party testing, provide years of field validation data showing their valves haven't failed in similar conditions.
Years of data.
Years, and they have to navigate labyrinthine certification cycles just to get their name on the approved vendor list.
So it's not enough to just build a good valve in a vacuum. You have to prove to a skeptical bureaucrat in London or a water commissioner in Delhi that your specific valve has already worked flawlessly for a decade somewhere else.
Exactly. The system is fundamentally designed to reward legacy and punish novelty. And JAS has been playing this specific game for over 60 years. The sources highlight that they have approvals from major municipal authorities both in India and abroad.
So they're already on the list.
They are, and once a municipality formally approves a JAS sluice gate for a tender, that approval acts as a massive, invisible barrier to entry for any new competitor.
It's a wall.
It is. A well-funded startup could theoretically build a cheaper, maybe even better valve tomorrow, but it would take them years, if not a full decade, to get the historical certifications required to even be legally allowed to bid on the major municipal projects.
Man.
That is their technology advantage, the proven, certified reliability of their designs across diverse global regulatory environments.
Okay, I understand the bureaucratic moat. It makes sense. It's a moat made of paperwork, municipal risk aversion, and time.
Yep.
But what about the cost advantage? If they are already safely on the approved list, how do they actually maintain those 51% margins on the factory floor?
That is where their heavy vertical integration comes into play.
Oh.
JASH operates 6 fully integrated manufacturing facilities, 4 in India, 1 in the US, and 1 in the UK.
Right.
They boast what the sources call 350-plus years of cumulative experience when you combine their various subsidiaries and heritage brands.
That's a lot of institutional knowledge.
It really is. And most fragmented rivals, what they do is buy pre-cast metal from a third-party foundry, pay a markup on it, and then just assemble the final product.
Oh, I see.
But JAHX does the pattern making, the actual molten casting, the heavy fabrication, the precise machining, and the final testing all entirely in-house.
So they literally control the entire digestive tract of the manufacturing process itself.
They do. And the financial result of controlling that entire process is massive.
Because they keep all the margin?
Exactly.
Right.
By vertically integrating their heavy fabrication, they capture the margin at every single step, keeping their final per-unit costs incredibly low compared to rivals who have to pay out margins to specialized subcontractors.
That makes a ton of sense.
And this structurally low cost base doesn't just help them win municipal water projects. It allows them to aggressively bid and win highly competitive contracts in other heavy industries, too.
Like what else?
We are talking about power plants, steel mills, cement plants, and petrochemical facilities, all of which require massive custom-built cooling water intake systems.
I hear you, and the data definitely supports it. But I'm going to push back on this concept of a durable moat for a second.
Okay, let's hear it.
When I think of a truly impenetrable economic moat, I think of strong brand switching costs or powerful network effects.
Right, like tech monopolies.
Exactly. Like once a company is fully integrated into the Microsoft software ecosystem, it's financially ruinous and painful to leave.
True.
Or think of a Class 1 railroad where literally nobody else is legally or physically allowed to build a track next to yours.
Right.
The sources explicitly state there is no evidence of network density here, and brand switching costs aren't strongly proven. A city can just buy a different valve next time.
They can, yes.
So aren't they ultimately just competing on being the absolute cheapest approved option on a government tender list? And if that's true, is that really a durable moat?
That's a fair point.
Because what happens if a massive state-backed Chinese manufacturing conglomerate decides they are willing to stomach the 5-year approval process, and then they come in and outprice JASH by 20%?
Yeah.
Doesn't the entire moat just dry up overnight?
You're touching on a fundamental vulnerability there, and your skepticism is entirely warranted.
Okay.
The moat is durable today, but it is absolutely not impenetrable.
Right.
If a well-capitalized competitor with structurally lower labor costs decides to endure the regulatory hazing period, they could theoretically compress JASH's margins severely.
Yeah, that's what I'm thinking.
However, we have to look at the physical terrestrial reality of what it actually takes to compete at this scale.
What do you mean?
The sources detail the massive physical footprint of JASH. Just one of their manufacturing units, an indoor, sits on 320,000 square feet of land.
320,000. So that's roughly what, 5 or 6 American football fields of just pure, heavy industrial factory space.
Yeah, exactly.
Yeah.
And it isn't just an empty warehouse.
Right.
Think about the heavy capital required just to acquire that land, pour the specialized high-load concrete foundations required to handle the vibrations of heavy iron casting.
Oh, I didn't even think about the foundations.
Oh, yeah, it's intense. You have to build the massive furnaces,
Yeah.
install the heavy-duty overhead cranes required to move 10-ton pieces of metal, and you have to recruit and train the specialized engineering labor.
Which takes years.
Right. It is a massive, daunting, upfront capital expenditure.
So it's not easy to just spin up a rival foundry.
Exactly. But beyond the sheer physical plant in India, their true defensive moat against a hypothetical, cheaper foreign competitor might actually be their localized production strategy.
You mean the facilities they own outside of India, closer to their export clients?
Right. The data points to this being a crucial advantage. They have a major facility in the United States via their subsidiary Rodney Hunt and a facility in the UK.
Okay.
This creates a powerful logistical moat.
How so?
Well, if a municipality in North America needs a massive, custom-designed water control gate, JASH can manufacture it, or at least do the final heavy assembly, much closer to the end user.
Oh, right. Because shipping is crazy expensive.
Exactly. They aren't just shipping raw tonnage across the Pacific Ocean, which is incredibly expensive, environmentally taxing, and subject to massive, unpredictable shipping delays.
Especially lately.
Right. Localized production drastically reduces lead times and logistics costs, which is often the deciding factor when a city is trying to keep a multi-million-dollar infrastructure project on schedule.
That makes total sense. So the moat is really a combination of 3 things.
Let's hear them.
Bureaucratic inertia preventing new entrants. The sheer terrifying capital cost of building a massive heavy metal foundry from scratch and having factories strategically located near the buyers to cut down on shipping 10-ton blocks of iron.
That's a perfect summary.
I get it.
Yeah.
Having established their dominant physical footprint and those beautiful 50% gross margins, this whole operation sounds like a license to print money. Like they should be bulletproof.
The financial profile certainly suggests a highly resilient business model on paper.
On paper, yeah. But the FY26 data shows they aren't bulletproof at all. They hit a massive wall.
They really did.
Because the sources paint a picture of a company that was flying high and then suddenly hit a massive, violent air pocket.
The recent data is incredibly stark.
Okay, walk us through the numbers.
Let's look at the fiscal year 2025, which in the Indian accounting system ends in March 2025. It was a banner year for them.
Right.
Their standalone operations revenue hit 465 crore rupees.
Just to translate that for our global listeners, a crore is 10 million rupees. So 465 crore is roughly 55 million US dollars, give or take, depending on current exchange rates.
Right, thanks for that. And that 465 crore revenue figure was up an impressive 38% year over year.
Wow, 38%.
Yeah. Their profit after tax, or PT, was 69 crore. The factories were humming, volumes were up, and their exports were booming.
Like how booming?
Exports accounted for about 60% of their total revenue.
Okay, so the machine was working perfectly.
Perfectly. But then we crossed the threshold into the current fiscal year, FY26. And the H1, the first half of the year, showed a severe, unexpected stumble.
Let's quantify severe for the listener, because we aren't just talking about a slight dip in sales here.
No, we're talking about their profit after tax dropping 52% to 24.57 crore.
52% in half a year.
Yeah. In the third quarter specifically, their operating margins dropped over 1,100 basis points year over year, down to 10.57%. Their PAT margin fell to 8.14%.
Dropping 1,100 basis points. That is an 11 percentage point drop in operating margin in a single year.
It's massive.
In the world of heavy manufacturing, where margins are everything, that is a catastrophic contraction. That's the kind of drop that keeps executives awake at night.
Oh, absolutely.
What on earth happened?
Yeah.
Did cities globally just suddenly stop buying water valves? Did the urbanization megatrend just pause?
No, the macro demand didn't vanish at all. The underlying need remained constant.
So what was it?
The culprits, according to the sources in management's own guidance, were a confluence of specific acute internal and external shocks.
Right.
They list four main factors. First, there was something referred to as the Kansas Project Legacy Loss Order.
Okay.
Second, U.S. tariffs on imported steel jumped from 25% to 50%.
Ouch.
Third, there were significant deferred deliveries of major export orders. And finally, they experienced a sudden 20% spike in employee costs.
Okay, we need to unpack the mechanics of each of these because just listing them out doesn't explain why they cause such financial violence.
Right, the mechanics matter.
Let's start with the Kansas project. What exactly is a legacy loss order, and how does a single project in Kansas blow a hole in the balance sheet of an Indian manufacturer?
The mechanics of heavy engineering contracts are notoriously unforgiving.
How so?
In project-based manufacturing, you often bid on a massive municipal contract years before you actually deliver the final product.
Years before. Okay.
A legacy loss order happens when a company wins a fixed-price bid based on certain cost assumptions. Let's say the price of raw steel, shipping rates, and labor costs back in 2021.
Right.
But because of unforeseen delays, maybe the municipality had permitting issues, or there were complex engineering redesigns required due to unexpected soil conditions at the Kansas site, or just global supply chain lags.
Like we've seen everywhere recently.
Exactly. Because of all that, JASH ends up actually manufacturing and delivering the product in 2024 or 2025.
I see where this is going. By the time they actually build the thing, massive inflation has happened.
Exactly.
The price of the raw iron ore has spiked, the cost of the electricity to run the furnace has gone up, but they're legally locked into the fixed price they agreed to 3 or 4 years ago.
Right.
So every single day they work on finishing the Kansas project, they are actively, mathematically losing money.
The contract literally becomes a financial liability rather than an asset. They are legally obligated to deliver the infrastructure, but the cost profile has completely inverted.
Man, that's brutal.
It is. That single bleeding project drags down the entire quarter's profitability.
Right.
And then, right as they are dealing with that, you layer on the unpredictable reality of global geopolitics.
The tariffs.
Exactly. As we noted, JSH owns the Rodney Hunt subsidiary in the United States.
Yeah.
When U.S. trade policy dictates that tariffs on steel imports jump from 25% to 50%, that immediately drastically hits the cost of raw materials for their U.S. operations. Or it significantly increases the cost of importing finished components from their own Indian plants into the American market.
It's wild to think about the butterfly effect of that. Macroeconomic trade policy, debated and signed in Washington, D.C., instantly and directly impacts the profit margins of a factory floor in Indore, India.
It's completely interconnected.
There's no buffer.
Yeah.
But what about the employee costs? The sources mention a 20% spike.
Yeah, that was another hit.
Why does a manufacturing workforce suddenly cost 20% more in a single year? That seems incredibly high for a mature industry.
While the sources don't provide a granular, itemized breakdown, a 20% spike in labor costs in the Indian industrial sector right now typically points to a few converging factors.
Okay, like what?
Well, India is currently experiencing a massive, broader manufacturing boom.
Right, everyone's building there.
Yeah, so there is intense competition for specialized engineering talent, heavy machinery operators, and experienced metallurgists.
Oh, so they're getting poached.
Exactly. To retain their highly skilled workforce against aggressive poaching from competing industrial firms or even the booming tech sector, companies like JSH are often forced to implement significant across-the-board wage hikes.
That makes sense.
When you combine talent retention efforts with the general baseline inflation in the region, labor costs can escalate rapidly.
Right.
And when we dissect JS's operating leverage, we really start to understand why these combined shocks, the legacy loss, the tariffs, and the labor spike, cause the profit drop to be so incredibly dramatic.
Operating leverage is such a crucial concept here. Let's explain how it works in heavy industry.
Okay, let's break it down.
Because JSH has incredibly high fixed costs, right?
Very high.
They have to pay their specialized engineering labor, maintain these massive 320,000 square foot factories, pay the energy bills to keep the foundries hot, and cover the significant depreciation on their heavy machinery.
Yep.
And they have to do all of that regardless of whether they ship one valve that month or 1,000.
The fixed overhead is immense and it's inescapable.
So because of those high fixed costs, Their margins expand beautifully when volume scales up, like we saw in FY25.
Right.
Once the factory's baseline costs are covered for the month, every extra valve they sell drops almost as pure profit to the bottom line because the factory's already paid for.
The upward trajectory of operating leverage is fantastic for shareholders.
But the inverse is brutally punishing.
Brutal.
The moment there is a hiccup, like a major export shipment being deferred to the next quarter because a cargo ship was delayed, or unexpected tariffs eating into the gross margin of a U.S. sale, those massive fixed costs transform into an anchor.
That's a great way to put it, an anchor.
You are generating less revenue, but your monthly factory burn rate remains exactly the same. They drag down profitability instantly and violently.
They really do.
Let me try another analogy to make the mechanics of this operating leverage super clear for the listener.
I like your analogies. Go ahead.
I like to think of JAS's business model as being very similar to running a company that caters massive, high-end weddings.
Okay. Weddings. Let's trace the parallels there.
So you run this elite catering company. You have a massive commercial kitchen you pay rent on. You have 5 master chefs on a high fixed salary. And you have a fleet of specialized delivery trucks.
Okay.
Those are your 6 costs. You pay them every single month, no matter what.
Right.
If you book 10 massive weddings a month, your kitchen is humming at absolute maximum capacity and you are highly profitable.
Because the volume is there.
Exactly. The cost of the food ingredients, the chicken, the fish, is variable, but the massive kitchen overhead is spread thinly across 10 different weddings.
Makes sense.
But if there is a sudden massive snowstorm, and 3 of those weddings get postponed to next year.
Like JASH's deferred export delivery.
Exactly. That's exactly like JASH's deferred export deliveries. You still have to pay your master chefs their full salary.
Yeah.
You still pay the massive rent on the kitchen.
Yep.
Suddenly, your profit margins for that month don't just dip a little bit, they get completely wiped out, even though you were still catering 7 big weddings. The fixed costs ate all the profit from the remaining revenue.
The mechanics of your catering analogy perfectly mirror their factory reality.
Right.
Furthermore, unlike a software company that receives a highly predictable, steady stream of monthly subscription revenue, JASH's revenue is incredibly lumpy by nature.
Very lumpy.
You win a massive municipal tender, you spend 6 months building the specialized equipment, and you get paid upon delivery and commissioning.
Okay.
The sources note that while they do receive advance payments to fund the upfront raw materials, their working capital cycles are agonizingly long.
How long?
Their receivables, which is the time it takes for a municipal customer to actually pay their invoice after the equipment is delivered, sit between 120 to 180 days.
Wait, 6 months?
Yeah.
You deliver a massive piece of critical infrastructure to a city, and you have to wait half a year to actually get the cash in your bank account.
Yeah, up to 6 months.
That requires an incredibly strong balance sheet just to survive the waiting period.
It does.
So here's my question to you, asking on behalf of everyone listening who is trying to evaluate this company.
Okay, hit me.
We see the 52% profit drop. We hear management citing the Kansas project, the geopolitical tariffs, the deferred deliveries. Are these just convenient excuses?
That's the big question.
Is this just management playing the classic game of the dog ate my homework, it's the macro environment's fault? Or is this genuinely a temporary perfect storm of blips before a massive second-half turnaround like management is promising?
That is the multi-million-dollar question that dictates the future of the company.
Right.
Management guidance, as detailed in the sources, remains aggressively optimistic despite the H1 crash.
Aggressively optimistic.
Very. They are officially guiding for a massive turnaround in the second half of FY26.
Okay, what kind of numbers are they projecting?
They're projecting total year revenues to cross 825 crore.
Wait, 825 crore.
Which implies an absolutely massive second half, considering the first half only generated 293 crore.
That is a huge jump.
It is. They're also targeting a total order book of 1,100 crore by the end of March 2026.
So they're just banking on a flood of new orders.
Yeah. They are telling stakeholders that the gross margin dip was entirely temporary, that they have aggressively implemented new pricing policies to counter the U.S. tariffs going forward.
Okay, that's proactive.
And that favorable currency depreciation will help offset some of their export costs.
So they are essentially betting the entire house that the worst is fully behind them, The Kansas project is flushed out of the system, and the structural tailwinds of global urbanization will fill their sails again.
They are, and structurally, it is worth noting that the company is built to weather these
Oh,
storms.
so?
They have a very low debt-to-EBITDA ratio of 1.24x.
Oh, wow.
They are essentially near debt-free on a net
That's
basis.
huge for a capital-heavy business.
Exactly. This means they aren't facing an existential cash crunch that would force them into bankruptcy or highly dilutive emergency funding during a bad quarter.
Right, they have breathing room.
But it does place immense, uncompromising pressure on their management's ability to actually execute the turnaround they are promising.
Which perfectly transitions us to the next phase of our analysis. Because if management is betting everything on this massive second half turnaround and executing flawlessly on an 1,100 crore order book, we have to ask.
Where is it coming from?
Exactly. Where exactly is this future growth going to come from? And more importantly, what could break along the way? What are the existential dragons on the horizon for JASH?
Let's start with the growth vectors, the path forward that management has laid out.
Okay.
The sources outline four main avenues for expansion. First is simple capacity expansion.
Meaning just making more stuff.
Right. They're investing heavily in capital expenditures to increase the physical throughput and efficiency of their existing 6 factories.
Yeah.
Second is deeper penetration in their home market of India, specifically capitalizing on the massive government municipal push for clean water infrastructure.
Riding the local wave.
Exactly. Third is geographic expansion, with a very particular focus on the Middle East, where there is currently a massive, sustained boom in the construction of new desalination plants.
Oh, desalination. That is incredibly heavy on valves and pumps.
Way extremely heavy.
The mechanics of taking raw seawater and forcing it through microscopic membranes requires immense, sustained pressure control. Standard valves would just get eaten alive by the salt and the pressure.
The physical demands of reverse osmosis in desalination are brutal on infrastructure.
Yeah, saltwater destroys everything.
It does. It requires highly engineered, corrosion-resistant, high-pressure valves. It's a perfect high-margin use case for JASH's specialized engineering capabilities.
Okay, so that's a smart target.
But the fourth growth vector is perhaps the most interesting: ecosystem expansion.
Ecosystem expansion, what does that mean?
The sources highlight a recent major acquisition where JASH bought a 50% stake in a company called Westtech for 2,911 lakhs.
Let's do the math on that. 2,911 lakhs is about 29 crore rupees, or roughly 3.5 million US dollars. What exactly does $3.5 million buy them in this context?
Westtech is a recognized, established U.S.-based provider of water and wastewater treatment process equipment.
Okay, so an American company.
Yes. And this isn't just a passive financial investment for JHH. It is a highly strategic, offensive move.
Why?
Historically, breaking into the U.S. municipal market as a foreign entity is incredibly difficult due to the Buy American provisions and the entrenched relationships of local players.
Right, cities like to buy local.
Exactly. Buying a 50% stake in Westtech gives JAHH an immediate established foothold and a trusted brand name right in the United States market.
Trojan horse.
In a way, the mechanics of the deal allow them to cross-sell their lower-cost Indian-manufactured valves into Westtech's existing American project pipeline.
That is clever.
It's a strategic way to aggressively diversify away from relying solely on local Indian municipal spending cycles without having to build a completely new U.S. factory from the ground up.
Okay, so the growth plan is actually very pragmatic. It makes sense. It isn't some blue sky pivot to artificial intelligence or blockchain.
No, it's very grounded.
You have a very grounded industrial plan. Build more factories, sell more to the Indian government, sell specialized equipment to the Middle East, and buy a U.S. partner to smuggle your products into the American market.
Exactly. It's all about brutal execution on the ground.
But what about those dragons? What are the risks that could derail this entire roadmap?
The sources outlines several very credible, potentially existential threats. The first is cyclicality.
Cyclicality, okay.
JASH is dangerously dependent on government infrastructure spending. In India, a major driver of their domestic revenue is the government's Jal Jeevan mission.
What's that?
It's a massive federal initiative aiming to provide safe, piped drinking water to all rural households.
Right. And massive government mandates mean massive guaranteed municipal budgets flowing down to equipment providers.
But the flip side of relying on government mandates is vulnerability to political shifts.
Of course.
What happens if the political winds change? What happens if there is a macroeconomic slowdown and the federal government decides to austerity cut municipal budgets by 20 to 30%?
Then the well dries up, literally.
The sources explicitly warn that if government spending slows, JASH's order book could have very quickly.
Have cut in half.
Yeah. We saw this exact scenario play out during the COVID dip in 2019 and 2020, where their revenue dropped significantly simply because government tenders dried up and bureaucratic approvals stalled.
So they are fundamentally at the mercy of the political budgeting cycle. If the government tightens its belt, JASH starves. What else is looming?
The second dragon is intensifying global competition.
Okay.
We discussed the strength of their bureaucratic moat earlier, but the reality is that low-cost Chinese and emerging Indian rivals are constantly trying to undercut them.
Right, especially on price.
Especially in the highly competitive export markets in the Middle East and parts of Europe. If JASH loses its strict cost discipline, or if rivals aggressively subsidize their bids just to win market share, JASH's export margins could compress rapidly.
Which leads right into the third risk, which I found absolutely fascinating when reading through the sources.
The regulatory risks.
Yes, specifically something called the EU CBAM. Can we really dig into the mechanics of this? Because it sounds like a massive, unprecedented geopolitical headache for a manufacturing firm.
It really is. It is a profound shift in global trade mechanics. CBAM stands for the Carbon Border Adjustment Mechanism.
Okay.
It is essentially a groundbreaking carbon tax implemented by the European Union on imported goods.
Let's unpack the mechanics of this carefully. How does a newly legislated European carbon tax functionally affect a factory operating thousands of miles away in indoor India?
To understand the impact, you have to think about JASH's core physical products, cast iron and steel. The production of cast iron in a traditional foundry requires immense amounts of thermal energy to melt the metal. Energy that is traditionally sourced from coal or other highly combustible fossil fuels.
Very dirty energy.
It is, by its very nature, a highly carbon-intensive manufacturing process.
Okay.
The European Union has they've decided to level the playing field for their own domestic, heavily regulated industries.
Makes sense from their perspective.
They decreed that if a company wants to import carbon-intensive goods into the European market, they have to pay a tax at the border equivalent to the carbon emissions generated during the manufacturing of those goods, regardless of where in the world they were actually made.
Yeah. Let me make sure I'm getting this. Europe is essentially saying, we don't care that your factory is legally operating indoor under Indian environmental laws. If you use dirty coal energy to melt that steel, you owe us a massive tax at the port of entry before you can sell it here.
That's exactly it. The mechanics of the tax are designed to ensure you cannot just offshore your emissions to countries with looser environmental regulations.
That is wild.
And the financial impact is severe. The sources estimate the CBAM tax could artificially raise JH final filling prices in Europe by 15 to 20%.
That is massive. We were just talking earlier about how their entire competitive moat against Western firms is based on a cost advantage derived from cheaper Indian manufacturing and labor.
Right.
If the EU suddenly slaps a 20% carbon tax on their valves at the border, that cost advantage is instantly and entirely neutralized in the European market.
Completely neutralized.
Suddenly, a French or German valve manufacturer operating a cleaner but more expensive local factory looks a lot more competitive on the final bid sheet.
It is a profound structural risk to their entire export growth strategy in developed markets.
I'll say.
The mechanics of CBAM force companies like JASH into a brutal dilemma. They must either rapidly and expensively decarbonize their Indian foundries.
Which would cost a fortune.
Oh, massive capital expenditure to switch to electric arc furnaces or renewable energy grids. Or they must accept permanently lower margins and lost market share in Europe.
That is a dragon with real teeth. But I want to zero in on the final risk mentioned in the sources because this one really caught my eye and speaks to the future of the industry.
Okay, what is it?
Technology disruption. The sources explicitly mention that JASH is currently still selling what are essentially 2000-era mechanical butterfly valves, and their research and development spend is shockingly low, less than 3% of their total revenue.
Yeah, they are very traditional.
Meanwhile, the sources note that major, heavily capitalized global competitors, like Xylem, are actively building smart, digital valves equipped with IoT, the Internet of Things.
The digital shift in municipal infrastructure is a very real trend.
Here's my question on the mechanics of this shift. A traditional mechanical JASH valve requires a human worker to physically walk up to it, visually inspect it, manually turn a giant wheel to adjust the flow, and maybe hit it with a heavy wrench if it gets stuck.
The old school way.
Exactly. A modern smart valve has integrated sensors. It measures the water flow rate and turbulence in real time. It detects microscopic pressure drops that indicate a leak forming 3 miles down the pipe.
Right, it's connected.
It connects to the municipal cloud dashboard and uses predictive analytics to schedule its own maintenance before it catastrophically breaks.
That's the pitch, anyway.
If JASH is purely committed to mechanical iron, and the entire world is moving towards smart, interconnected infrastructure, are they going to become the blockbuster video of water valves? Are they just going to wake up obsolete in 10 years?
The mechanics of terminal value in industrial manufacturing often hinge on this exact question.
So it's a real threat.
The risk of obsolescence is real. The sources note that a continued lack of digital innovation could render up to 20% of their product portfolio uncompetitive in the near future.
20%, wow.
Especially in high-end, newly funded projects like modern desalination plants or advanced wastewater recovery facilities, which increasingly demand automated, data-driven, centralized control systems.
So they have to upgrade.
However, we must also deeply consider the practical reality of the end user.
What do you mean by the practical reality?
Think about the environment these products operate in. Think about a remote, severely underfunded municipal pumping station in rural India, or a massive, brutalist steel mill environment full of dust, heat, and vibration.
Right. Not exactly a clean room.
Do the operators there really want a highly sensitive, cloud-connected digital valve that requires a specialized software engineer to calibrate?
Probably not.
And a valve that might completely shut down the plant if the local Wi-Fi router fails? Or do they want a massive, dumb, cast-iron mechanical gate that has worked flawlessly for 50 years, has no fragile circuit boards to fry, and can be fixed by a local mechanic with a sledgehammer and some grease?
Ah, I see. The dumb but incredibly durable argument. There is a certain elegance to machinery that simply refuses to break.
The data suggests there is a massive, highly persistent market for hyper-reliable, purely mechanical infrastructure.
Especially in those harsh environments.
Particularly in harsh industrial environments or in developing regions where the surrounding digital infrastructure and power grids are unreliable. JASH's current strategic bet seems to be on remaining the absolute best in the world at the mechanical foundation.
Stick to what they know.
Exactly. But the sources do note that their extensive in-house testing facilities position them well for future automation upgrades if they finally choose to pivot.
It's all about timing then.
The existential risk is timing. If they wait too long to integrate sensors, the smart competitors will lock up all the lucrative premium municipal contracts in the developed world, relegating JAH to only the low-margin, dumb infrastructure projects.
It's a fascinating strategic tightrope to walk. Think about the mental bandwidth required here.
It's a lot.
Navigating unprecedented global carbon taxes, deciding the exact moment to pivot from mechanical iron to digital sensors, physically integrating a massive U.S. acquisition like Westech across time zones.
All at the same time.
Doing all of this while simultaneously trying to recover from a 52% profit drop requires exceptional, incredibly steady leadership. Who is actually steering this massive, heavy metal operation through these waters?
According to the sources, the leadership structure is heavily concentrated within the founding promoter family.
The founders.
Pratik Patel is the chairman and managing director, and Suresh Patel serves as the executive director. The board of directors overseeing the company consists of 8 individuals.
And what does the governance structure actually look like? Because whenever you look at a family-run industrial company, especially in emerging markets, corporate governance and oversight is always a key area of scrutiny for global investors.
The board structure is actually quite solid from a strict regulatory compliance standpoint.
Oh, good.
Exactly 50% of the board, 4 out of the 8 directors are categorized as independent directors. There is also 1 female director on the board.
Okay, so a decent mix.
Having a 50% independent board meets high regulatory standards and implies a necessary, legally mandated level of professional oversight. This is generally interpreted as a positive signal for a company with such heavy family involvement, considering there are 3 members of the Pell family sitting on the board in total.
Okay, so the organizational chart looks compliant on paper. But what do we actually know about how they operate in the real world? How do they make the hard decisions?
This is where the analysis has to pivot, and it becomes largely about what is missing from the sources rather than what is explicitly
What
stated.
am I missing?
We have their names, we have their formal titles, and we can see from the filings that they have been in place since at least fiscal year 2020. But the sources lack any concrete narrative details on the Patel's historical execution track record during severe crises.
Really?
Yeah. We don't have documented examples of how they navigated previous severe economic downturns, other than the binary fact that the company obviously survived them.
I think this is a critical point to highlight for you listening. When you are analyzing a company, or really when you are analyzing any complex geopolitical or economic topic from a stack of documents, noting exactly what isn't in the source material is just as important a critical thinking skill as reading what is there.
Absolutely.
The voids in the data are often where the real risk hides.
The silences in the financial data often speak volumes about potential hidden vulnerabilities.
Right. Let's look at the facts we do have versus the facts we don't. We know they have managed to build a nearly debt-free balance sheet.
Yes.
A debt-to-EBITDA ratio of 1.24x for a heavy manufacturing firm is objectively fantastic. It shows a history of extreme fiscal prudence. They aren't betting the company's survival on wild, debt-fueled expansion sprees.
No, they're conservative.
But on the flip side of that coin, we don't know exactly what their fundamental capital allocation style is. Crucially, the sources don't tell us how they actually incentivize their executive team.
That's a huge blank spot.
Are the Patels and their lieutenants rewarded with bonuses purely for driving sheer top-line revenue growth? Or are their incentives tied strictly to return on invested capital?
The mechanics of executive compensation dictate corporate behavior. If you pay a management team massive bonuses just to grow top-line revenue at all costs, human nature dictates they might aggressively take on highly risky, ultimately unprofitable projects simply to make the revenue chart go up, ignoring the damage to the bottom line.
And doesn't that tie directly back to the mechanics of the Kansas Project legacy loss we dissected earlier?
It's very possible.
The fact that a massive, financially toxic contract was sitting on their books, just waiting to detonate their quarterly margins, suggests there might have been significant blind spots in their operational risk management and their bidding processes a few years ago.
That's a very fair assessment.
Was the executive team structurally incentivized to aggressively win that Kansas bid at all costs just to show market expansion, completely ignoring the margin risk of a fixed-price contract in an inflationary environment? We simply don't know, because the incentive structures are entirely missing from the data.
It highlights a fascinating dichotomy in their corporate leadership profile. On one hand, you have an incredibly stable, multi-generational leadership team that has successfully built a dominant export-heavy business from central India and maintained a pristine, conservative balance sheet.
Right.
That takes serious, undeniable operational skill and patience.
Definitely.
On the other hand, the sudden, violent shocks to their profitability suggest they might internally struggle with the organizational agility required to navigate rapid geopolitical changes, like sudden U.S. tariffs, or they might lack the strict operational discipline required to ruthlessly weed out toxic, low-margin contracts before the ink is signed.
It really paints a picture of a company caught in a profound transition. They're trying to scale up from being a highly reliable, regionally dominant manufacturer into a truly global infrastructure player.
And that transition is hard.
Very hard. And the mechanics of that transition are actively stressing every single seam of the organization. Which brings us to the end of our deep dive today.
What a journey.
Let's do a rapid-fire recap of the journey we've just taken, synthesizing how JASH's massive physical machinery, their turbulent economic reality, and their highly complex future prospects all merge into a single cohesive narrative.
We started by exploring the sheer, intimidating scale of the macro need. We looked at a $150 million company capturing just a tiny sliver of a $20 billion global market.
A market driven by the unstoppable, unavoidable realities of global urbanization and escalating water scarcity.
We saw the mechanics of how they built their moat. It wasn't built out of flashy consumer brand loyalty, but out of the agonizing, slow grind of municipal red tape and the sheer, immovable physical weight of owning massive, vertically integrated iron foundries.
We then examined the painful, mechanical reality of operating leverage. We explored how a company humming along beautifully with 50% gross margins can suddenly see its profits crash by 52% in a matter of months.
all due to a perfect storm of macroeconomic factors.
Geopolitical tariffs dictated in Washington, delayed shipping schedules, and the lingering ghost of a poorly structured legacy contract in Kansas.
And finally, we mapped out the dragons on the horizon. The company's future growth hinges entirely on how this family-led board navigates the existential, structural threats of European carbon taxes, neutralizing their historical cost advantage.
The looming inevitable disruption of IoT smart valves rendering their mechanical iron obsolete, and the massive execution risk of integrating strategic acquisitions like Westech in the United States.
It's an incredibly fascinating story about the physical realities of the world we live in.
It really is. And I want to leave you, the listener, with a final thought to mull over. Something that struck me deeply as we were putting the research for this deep dive together.
What's that?
Consider what we might call the paradox of invisible infrastructure.
The paradox of invisible infrastructure.
Think about the mechanics of it. Companies like JAH are the literal physical gatekeepers of human survival in the 21st century.
They are.
They are manufacturing the heavy machinery that manages the water, keeping billions of people alive. The machinery that prevents our densely packed cities from drowning in their own waste, and the equipment that cools and powers our most vital heavy industries.
Huge responsibility.
Huge. Yet, despite this monumental responsibility, they operate entirely in the darkness, entirely in the background of our collective consciousness.
Nobody thinks about them.
Right. They are bound by 2000s-era mechanical technology, largely ignored by the public, rarely discussed by the media, and often overlooked by the broader financial markets.
Until something goes wrong.
Exactly. They remain invisible right up until the exact, terrifying moment. A massive valve breaks, a city floods, or a geopolitical tariff suddenly hits the supply chain.
That's the only time they make the news.
So the next time you casually turn on your tap to get a glass of water, ask yourself a question. In an age where we are completely, utterly obsessed with artificial intelligence, the cloud, and digital realities, is this single most physically vulnerable point of our entire modern civilization actually a massive, silent cast iron sluice gate made in a foundry and indoor?
It is a profound question and a stark reminder that the entirety of our digital world still relies completely on the integrity of the physical one.
Thank you for joining us on this deep dive.